Hello and welcome to this video on balancing chemical equations algebraically. As you can see, lead nitrate reacts with sodium chloride to give you lead chloride and sodium nitrate. The moles on the reactant side and the product sides are not balanced. So let's try and balance them. Okay. We may substitute the missing number of moles by some kind of variables. Let us represent the number of moles of lead nitrate by A, those of sodium chloride by B, those of lead chloride by C, and those of sodium nitrate by D. The next step is to form equations using these variables. Coming to the left hand side, we have one atom of lead, so we may say that 1A equals 1C. Now that is because left hand side has one atom of lead and the right hand side also has one atom of lead. So A equals C. We can put a tick on the element that we form an equation with so that it doesn't get repeated again and again. Coming to the next element, nitrogen. On the left hand side we have two atoms of nitrogen. So we may say that 2A equals 1D. That's because on the right hand side there is only one atom of nitrogen. Now coming to oxygen. On the left hand side there are 6 atoms of oxygen. So we may say that 6A equals 3D, as there are 3 oxygen atoms on the right hand side. Now coming to sodium chloride. We have one atom of sodium on the reactant side. So that gives us B equals D. The reason is there is 1 mole of sodium on the reactant side as well as on the product side. Now coming to our last element, that is chlorine, we can say that P equals 2C. That's because on the left hand side there is one atom of chlorine and on the right hand side there are 2 atoms of chlorine. So now we have 1, 2, 3, 4 and 5 equations. Okay. The next step in balancing is to assume any one of the variables as being 1. So let us assume that our A equals 1. Therefore, if A equals 1, then C also equals 1 because A equals C. So we have solved the first equation. Now coming to the next equation, we have 2A equals 1D. That implies 2 into 1 equals D, or simply D equals 2. Now coming to the third equation, the equation is between A and D. Well, we have the values for both A and D, so we need not solve the third equation. Now going to the fourth equation, we have B equals D. So therefore it implies that B equals 2. And finally the last equation is between B and C. But by now we have got all the values for all the variables and therefore we need not solve the fifth equation. Fine. So now that we have got the values for all the variables, the next thing is to substitute these values in place of the assumed number of moles to check whether the equation is balanced. Since lead nitrate had the variable A, let us substitute 1 ahead of lead nitrate. Rather, I take another color. Okay, so I have 1 lead nitrate. Similarly, sodium chloride was having B as the number of moles. So I may say 1 mole of lead nitrate reacts with 2 moles of sodium chloride to give you, okay, C moles of Pb2Cl2. That is 1 mole of PbCl2. And also it gives you D moles of sodium nitrate. Now since D is 2, we may write 2NaNO3. Now let's see if the equation is balanced. On the left hand side there is 1 atom of lead. On the right hand side there is 1 atom of lead. So lead is balanced. On the left hand side there is 1 nitrogen atom. On the right hand side, on the left hand side there are 2 nitrogen atoms, and on the right hand side again there are 2 nitrogen atoms. So nitrogen is balanced. Oxygen, there are 6 atoms of oxygen on the left hand side, and the right hand side has 6 atoms of oxygen. So oxygen also is balanced. And now coming to sodium chloride, there are 2 atoms of sodium on the left hand side and 2 atoms of sodium on the right hand side. So again sodium also is balanced. And now coming to chlorine, left hand side has 2 atoms of chlorine and right hand side also has 2 atoms of chlorine. So all our elements are balanced. Thank you for watching this video. I hope you liked it.